Now it's your turn to identify the key features from the graph of a parabola. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. In this first graph, we can see a parabola that appears to have a minimum point of -2, 1, and points upward. We see arrows on each end, and we can see that it's passing through that point 0, 5. So let's record this. Looking at the key features, the first one we're looking at, does it open upward or downward? And we've identified that it opens upward. The vertex, since it opens upwards, will be the lowest point on that graph. So let's label that off here. We see this lowest point, and it's the point -2, 1. So I'll write that down as the vertex. The axis of symmetry is then the line that passes through that vertex. So we can draw this line, and I'll draw it as a dashed line. And this is a vertical line, so we can define it with the equation x equals -2. So that axis of symmetry is then the line x equals -2. The horizontal intercepts, in this case, would be where the graph passes through that x-axis. And so these are x-intercepts, since our variable on our horizontal axis is the x variable. And in this case, there are none. The vertex is above that x-axis, and this parabola points upward, so we do not have any horizontal intercepts here. The vertical intercept, which because our vertical axis is labeled with y, is going to be the y-intercept. And looking at that parabola, we see that this passes through the point 0, 5. So our vertical intercept here is the point 0, 5. Looking at the domain, we can see that there's these two arrows on the end of this graph are pretty important. That means that this function continues on indefinitely, upward, but also outward, as we see the curve of that. So the domain here will be all real numbers, and as we write that as an interval, we can write that as the interval -infinity to infinity. The range in this case is we're going to use that vertex to determine the range. We see that the point -2, 1 is the lowest point on that graph. So the lowest y value we have is 1, and then we have all y values above that included also. So the range will be the interval from 1 to infinity, and we put a square bracket on 1 because that number 1 is included in the range, and an open rounded bracket on infinity simply because it's not a number and we don't include it. It's just showing that it continues on indefinitely in the positive direction. Coming over to this next graph, the first thing that we want to note are that the axes are labeled with t and y. The horizontal axis is labeled with t, and the vertical axis is labeled with y. Looking at the graph, we can see that this parabola opens downward, and then we see that it hits that t-axis at 3, 0, and so that maximum point is right on that t-axis. So let's get started in writing down all of this key information. We just noted that this parabola opens downwards. Let's write that down. And then the vertex is going to be the maximum point on this graph, and we can see that that's the point 3, 0. So our vertex is the point 3, 0. And then our axis of symmetry is going to be the vertical line that passes through that vertex. So let's draw that in. So we'll draw a vertical line through that vertex. And because this is a t-axis, this vertical line is going to be defined by t equals 3. And that's our axis of symmetry. The entire graph of that parabola is symmetric around that line. So our axis of symmetry here is going to be the line t equals 3. Our horizontal intercepts here, because our horizontal axis is the t-axis, will actually be a t-intercept. And we're only going to have one, because our vertex we hit that t-axis and then it comes back down. There's only one horizontal intercept here, and so that vertex and horizontal intercept are the same here. So we have the point 3, 0 for the horizontal intercept, which again in this case is a t-intercept because that horizontal axis is the t-axis. Our vertical intercept is going to be where we cross that vertical axis, and again here this is our y-intercept. And looking at where that hits, I can see halfway between -4 and -5, so that's the point 0, -4.5. So our vertical intercept or our y-intercept here is 0, -4.5. Looking at the domain, I again want to note that these arrows on the end show that this graph continues indefinitely in the downward direction, but also outward. So our domain here will be all real numbers. We can write that as the interval from -infinity to infinity, and of course with open rounded brackets on each side. The range here will be all possible outputs, and so we see that the maximum value for y is 0. So we need all numbers up to 0 and smaller than 0. So we'll write that as the interval from -infinity to 0, and we write an open bracket on -infinity and then a square bracket on 0.